So we started with electrostatics definition. We've seen electric charges. SI unit is coulomb, CGS unit is stat coulomb, and 1 coulomb is 3 into 10 to the power 9 ESU. Minimum charge in the electron that we've been using in our electric potential chapter, electric flux also we've used this E, that is electronic charge. Then I discussed with you that the stronger nuclear forces do not allow the protons to move out, whereas the weaker electrostatic forces allow the electrons to get transferred. So it's basically the transfer of electrons that occur, not the protons do not. And we also saw that when a body gains electrons, the mass increases. When a body loses electrons, the mass decreases. Then in charging by friction, we saw two bodies are rubbed against each other, and this question we saw. And after that, we have seen charging by conduction, which will be utilized in the Coulomb's law also. So in charging by conduction, I told you two bodies are just placed beside each other. They are not rubbed against one another. Okay, so that is charging by conduction. Now, I also told you that when you have two bodies that are identical, the charge gets divided equally. Means you just use the formula Q1 plus Q2 divided by 2. If the bodies are identical then. So we practiced a question also. So we have to start with charging by induction. Now, for understanding charging by induction, see, there's a neutral body. This body is neutral right now. When I say the term neutral, it means the amount of positive charges and negative charges are equal in number. This is a, let's say this is a conductor. This is a conductor. It has positive charges. These are the positive charges. And these are the negative charges. Now you can see from the figure the amount of positive charges and amount of negative charges are exact equal in number. Now what do I do here? I brought a glass rod and I made this glass rod completely positive charge. So what do you think, Marwa? Which kind of charges will be attracted towards the glass rod? Positive or negative?
Charge.
Negative. So one by one, the negative charges will start coming towards the glass rod like this. And ultimately, what will happen? Ultimately, the positive and the negative charges will be separated like this. Now, this method is called as induction. This is what is the method which is referred to as induction. Okay, this whole process is called as induction, which is what? This is basically a temporary electrification. Temporary electrification of charges. It's the temporary electrification of charges. The negative charges are present on one end and the positive charges are present on one end. So the charges have been separated. But till when? If I'm holding the glass rod, this is the conductor. Let's say this is the conductor, okay? And I have this glass rod over here. I'm holding this glass rod. So by the time, till the time I'm holding this glass rod, okay. So I was saying till the time I'm holding this glass rod, the electrons have been separated like this. See, the negative charges are towards this end till the time I'm holding this glass rod and the positive charges are towards this end. Now see, as soon as I remove the glass rod, what will happen? Positive, negative, they'll recombine and it will become back to neutral. So you just hold the glass rod and the charges are attracted and they are separated. That's why the term temporary has been used, temporary electrification. So the charges that are separated through the help of temporary electrification only, these are called as induced charges. These are the induced charges, all of this. And the charges that help them to get induced are called as inducing charges. These are inducing charges and the whole process is called as induction. This whole process is called as induction, which is the temporary electrification of the charges. So what is induction? When a charged body is placed near a neutral conductor, it induces charges due to what? Due to redistribution of electrons. Due to redistribution of electrons, the charges have been separated. So how did we start our whole process of induction? Body was, Aisha, I'm repeating, so pay attention. Body, there's a conductor which has equal amount of positive and negative charges. Means the body is neutral right now. It has negative charges, it has positive charges. We bring up a glass rod which is positively charged. So negative charges are attracted towards one end and the positive charges are left. Slowly, gradually, the negative charges get attracted towards the side. Ultimately, positive charges are on one side and the negative charges are on the other side, like this. But this is possible till the time I'm holding this glass rod. As soon as I remove the glass rod, the positive negative will recombine and the body will become back to neutral. So this process of temporary separation of the charges is called induction. The charges that get separated are induced charges, and the charges that are helping in the process of induction are inducing charges. Is it clear that last method that was there? Clear? Aisha, Marwa?
Ma'am, so the body gets the charge by the magnetic field, the field, if it
No,
enters the
no, not magnetic field. Magnetism will come only in your
electric
electrodynamics.
field, sorry, electric field.
Electric field.
Yeah.
What, Aisha? What is your question?
Ma'am, so if the neutral body is brought to a body which has magnetic field, so the neutral body will also get charged because of the electric
Electric field.
field.
If this has electric field, see, electric field is a property of a single charge. So that is not related with whether the positive, negative are together and making the body neutral or not. It's a property of single charge. You have nothing in universe except one charge. That will also have its electric field. Okay,
Yeah.
please write it. Done? Now there are questions based on charging by induction that comes, but before that, there's a very small topic earthing that you should know. You must have already heard about it in your lower classes earthing, especially in your class 8. This topic was there. Now, when you connect the body directly to the surface of Earth, is what is meant by earthing. See, earthing means like the human body is a conductor. If you have excess of electrons in your body, what happens? You are standing on the earth. The electrons drain out to the surface of the earth. This process is called as earthing. Whatever are the excess of charge, like if you have seen, there are, I don't know, at your places in India, at least you can witness this, large, huge trucks that are being taken and driven on the roads. They have a metallic wire-like structure, metallic pipe-like structure, which is constantly touching the road while it is moving. This is because when these heavy vehicles move, there is a chance of charging by friction, right? Because the vehicles are moving on the roads are irregular surfaces, tires have irregularities in them. So when the tires are moving across the road, it can lead to sparkle or electric shock, and it may catch up wire at the end. So to avoid that, the metallic rod is connected. Now, why a metallic rod? Metals are conductors. Conductors means they allow electrons to pass through them. So from these heavy trucks and vehicles, the electrons go through the metal wires, and through the metal wires, they go to the surface of Earth. So that is also earthing. Earthing means in any form you are connecting the body with the Earth, and the excess of electrons are getting drained back to the surface of Earth. That is what is meant by earthing. Now coming back to our topic of electrostatics, what do we do? Suppose I have a sphere, okay, and I put it on an insulating stand. This is a sphere. This is an insulating stand. Why insulating stand? So that there is no connection between the sphere and the Earth. Let's say it has excess of charges, positive, negative, and all. You will see this symbol. In your regular circuits also, in your chapter 2 you have capacitors, there you will see. In your chapter 3 you will have resistors, there you will see. In your chapter 6 you have inductors, there you will see. So this symbol is representation of earthing. Earthing is represented by this symbol. This is the representation of earthing. Means you have connected the sphere with the help of wire to the surface of Earth. Now electrons can travel if extra electrons are there in the body. Like if the body is negative, the body, if it is negatively charged, it has excess of electrons. Electrons will gradually move through the wire and go to the surface of Earth. Earth is so huge in size, it is so huge that these extra electrons can be accommodated on the surface of Earth or within the surface of Earth easily. There is no trouble in that. But you cannot make a device that can store so much of charge. So that's why we directly connect it to the Earth. If the body is positively charged and then you connect it with the surface of Earth, so some extra electrons from Earth can also travel to the body. From the positive body, electrons move from Earth to body. Important is this negative one. Electrons move from the body to the Earth. Like there's a question. Make this sphere positively charged. This is a question from your NCERT. Now class, look. This is the sphere, and this has an insulating stand over it. Insulating stand is put so that the charges are directly not in this contact with Earth. If they are in direct contact with Earth, all the charges will be drained off directly. So in order to avoid that, this system is made. Now this has positive charge, this has negative charges, right? It has positive charges, it has negative charges. Now, this body has to be made completely positive charge. So the glass rod that I am bringing has to be negatively charged or positively charged. What do you think? What would you suggest? It should be positive or negative? You have to make this sphere as completely positively charged. So this glass rod should contain negative charge or positive charge? Huh? Any idea? Any guesses? What do you think? See, if this is positive, it will attract the negative charges. Negative charges will be intact. We want the sphere to be positively charged. So, in order to make the sphere positively charged, you should bring the negative charges. Negative charges can only bring up the positive charges, not towards one end. Yeah? No.
Won't the body be neutral?
What about the body is right now neutral? Right now, the body is neutral. This is what you're asking, Aisha?
Yeah.
We brought a negatively charged glass rod because right now the body is neutral. So, what will happen if you bring up a negatively charged glass rod? This already has negative charges. It will attract positive charges at one end, and as a result of which, negative charges will be on the other end. Now, there is a problem in this. As soon as I'll remove this glass rod from the picture, it will again become back to neutral. Positive, negative will recombine, and this will become back to the neutral from where we started our whole calculation. So, in order to avoid that, what do? Now we connect it with the surface of the earth. So what will happen if I perform earthing right now? See this step. This step is basically denoting that earthing is taking place here. So if earthing is taking place here, then what will happen? All the negative charges will be drained towards the surface of earth. So now my negatively charged glass rod is present, but only positive end is present like this. Negative charges have gone to the surface of earth. Now you disconnect the wire. There is no tension. What will happen? You disconnect the wire, you remove the glass rod. Now when you remove the glass rod also, see this is the sphere present on the insulating stand. You remove the glass rod. It only has positive charges. Let it recombine. Nothing will happen. The positive charges only will be redistributed. So finally, after this, you make a sphere which is completely positively charged. Okay. Is that clear? This is a question from your solved examples of NCRT. Is this clear?
Yes, ma'am.
Okay, good. Write down this part from you. Just make a small note point on everything. Remember one thing. Since we are doing potential, you should know potential becomes zero in case of earthing. Please write it, class. Then we'll see properties of charges. There we have a formula of
And
quantization.
potential becomes zero because the body is only having positive charges.
No, not because of that. The potential becomes zero because the charges are traveling. There is a property called as sharing of conductors. So in sharing of conductors, the excess of charges move. So extra of charges move. So the same potential is achieved till the time the same potential is achieved. So potential at both the ends is the same. So difference becomes zero. That's why potential is zero. Okay, this we'll study in sharing of capacitors, sharing of conductors in chapter 2. That time we'll discuss it properly.
I'm done.
See, now let's come to the properties of the charges. The first property is very easy. It's the additive nature of charges. Now, additive nature means, see, charges are scalar quantities. So, scalar quantities can be directly added or subtracted. That is what is meant by additive nature of charges. Okay, see, like if I have a body and there are few charges, let's say plus 2 coulomb, minus 3 coulomb, plus 1 coulomb, like this, many charges are present. So when I have to calculate the net charge, the charges have this property that they can be added. Added means that you can add them using algebra, like plus, just a minute, just a minute. Yeah. So net charge can be added or subtracted. Like see, plus 2 coulomb minus 3 coulomb plus 1 coulomb. So my 2 minus 3 is minus 1 plus 1. This is 0. So all charges can be added using algebra. Second is conservation of charges. So we have studied it in detail that charges can neither be created nor be destroyed and they just get transferred. We have seen how charges, and charge by charge we mean electrons, how electrons are transferred from a positively charged body to a negatively charged body. Means where from wherever they lose or they exit, that body becomes positive, and in the body where they enter, that body becomes negative. We have studied it in detail in the previous class, where I described the nuclear forces also, electrostatic forces also. Refer that. Third says invariance of charge. This means charges do not depend on speed. See, this is the difference from where your difference between the mass and the charge comes. See, when we're talking about the masses, masses are also intrinsic properties of matter. Like charges are intrinsic properties of matter, fundamental concepts. Masses are also fundamental concepts. So, what's the difference between a charge and a mass? See, mass is a scalar quantity, charge is also a scalar quantity. But masses will always be positive, will be zero, that's it. Maximum a charge can be zero, that's it. But regarding charges, charges can be zero, negative, positive, all the values are possible. So this is one major difference between a charge and a mass. Second difference is that when we're talking about the mass, there's a formula. The mass of a body is rest mass divided by under root 1 minus v square by c square. This is a formula that was present in your class 11th textbook somewhere. I don't know you people have studied or not, but this is basically the rest mass of the particle. So when we are talking about the normal masses, See, from this formula, you can see mass depends on the speed. But see, in case of charges, charges travel very fast. You just switch on the circuit and the bulb glows, right? The tube light lightens up. You're asking?
What's C?
C is the speed of light. C is the speed of light, which is 3 into 10 to the power 8 meter per second. M is the rest mass. V is the speed of the particle. Now, in
Velocity.
V, yeah, V is the velocity of the particle. This is the velocity of the light. So, and it's the mass. So, according to this formula, masses are of any object, of any body that we talk about, any object that we talk about, masses have a limitation. Maximum, what can be the mass? Even what can be the speed? If a body is moving with a very high speed, it will be 3000 kilometer per hour, something like this. Or maximum more than that, 4000, 5000. That's it. But regarding charges, the charges have a very high speed. See, as soon as you switch on your circuit, your light glows up. So why? Because the speed of the charges are so fast that travel in your wires very fast. We'll study all these things in current electricity. But charges, so what happens? This value of velocity is very high for charges. So in return, what happens? This denominator becomes comparable, it gets cut. Right? V square and C square almost become similar. So they'll get cancelled. Root 1 is 1 only. So mass for the charged particle becomes independent of the speed. Right? So charges do not depend on the speed because their speed is very high. So their rest mass formula is not valid for them. This formula isn't valid for the charges. Masses can can live without the charges, cannot live without the charges. Both are possible. Like few particles are there that do not have charge. See, there is a possibility that a particle is there, that a body is there which does not have any charge. Like neutrons. Neutrons are neutral particles. They do not have any charge. But opposite is not possible. Charges cannot exist without masses. Every charged particle has its mass, except photons. Photons mass is zero. But don't go into this much of detail. This is not required at your level. What you need to remember is charges do not depend on the speed because the speed is so high. So the ratio gets divided and it becomes independent. Is this third point clear? Yeah? No? Yes. Marwa,
Yes,
Aisha.
ma'am.
Yeah?
Yes,
Marwa,
ma'am.
what about you?
Yeah, yeah. Yes, ma'am.
Yes, ma'am. So when we're talking about the quantization of charges, the fourth property is the most important property out of all properties. See, in the initial class, one class that we had before the first backup class, I told you that one electron has 1.6 into 10 to the power minus 19 of charge. This much of coulomb is present in one electron. So if I take two electrons class, two electrons, so won't it be 2 into 1.6 into 10 to the power minus 19 coulomb?
Yes,
Double of it.
ma'am.
If I take 3 electrons, it will be 3 times E. So 3 into 1.6 into 10 to the power minus 19 coulomb. Similarly, 4E. So 4 times 1.6 into 10 to the power minus 19 coulomb, like this. 5E, 6E till nth E. What will nth E be? N into 1.6 into 10 to the power minus 19 coulomb. According to this, we have what's the total charge there? N times E. This is the formula of the charge then. It's a very important formula. See, what is Q? Q is the charge. What is N? N is the number of electrons. And what's E? It's the electronic charge, which is 1.6 into 10 to the power minus 19. This value is the electronic charge. What is quantization of charge exactly? See, quantization basically means that charges are integral multiples of electronic charge, which is this E. What is meant by this? Let us understand. When it says that charges are integral, see, these are integers: 1 electron, 2 electrons, 3 electrons, electrons. Means n is any number starting with 1, 2, 3, 4, etc. So these are proper integers. You can never have 1.5 electron, 2.5 electron, 2 by 4th of electron. This is not possible. So when we're talking about the charges, charges are integral multiples of this number. See, one you will get 1.6 into 10 to the power minus 19. Second is 3.2 into 10 to the power minus 19. Next is 4.8 into 10 to the power minus 19. So these are all multiples of this value, 1.6 into 10 to the power minus 19. So that's why we say charges are integral multiple, because this is a proper integer. This is an integer. So integral multiple of electronic charge. Is the fourth point clear?
Yes, ma'am.
Okay, write down all the 4 properties. Now we'll come to the numericals. Please write it.
I'm done.
Just text me done once you've written. Okay, let us discuss some questions. See, this is the first question. It is saying calculate the number of electrons corresponding to 1 coulomb. Means the charge is given as 1 coulomb. Now you have to find out the number of electrons. Electronic charge will not be given to you in the question. So 1.6 into 10 to the power minus 19. This should be remembered by you. So see, Q is equal to NE. Now we need to get N. It will be Q by E. So Q is 1 coulomb. E is 1.6 into 10 to the power minus 19. So when you solve this, this will be 6.25 into 10 to the power 18 electron. Very easy question. Charge is 1 coulomb. Calculate the number of electrons. Easy? Clear?
Yes, ma'am.
Just try this. We'll practice some more questions from your previous year's board exam. We'll practice. Since 2 years, none of the questions have come in your boards from this topic since 2 years.
I'm done.
Okay. This question I'll discuss later. First, let me discuss the previous year's questions. Yeah. This question came once. It looks very lengthy. Class, it's very easy. It's just based on the properties of the charges. This says that in an experiment, 3 microscopic latex spheres are spread into the chambers. Okay. And they and become charged with the charges +3, +5, -3 respectively. All the 3 spheres come in contact. For basically what it is saying, initial lines were that 3 spheres are present. One is +3e, one is +5e, one is -3e. They come in contact for a moment, they get separated. And it is asking now, once they came in contact, now they are separated. Plus one thing before we begin, for which method of charging is it if they are brought in contact? If they are brought in contact and they are getting separated, which method of charging is it? Three methods we did. Charging by friction, charging by conduction, charging by induction. Which one is it? Hmm? Charging by conduction class. We've done it multiple times now. This is charging by conduction. In friction, both the bodies are rubbed against each other. In charging by conduction, you just put two bodies in contact with each other. That's it. The charging occurs because of the contact. This is what we've studied already. Now, C classes. This is saying when they are brought in contact, this is a charge, this is the sphere, this is one more sphere, and this is one more sphere. So it is saying what are the new charges on them. Now, see, we have no other information to solve this question except the options. So what do we do? See, what is the initial charge? What's the total initial charge? Plus 3 electron, plus 5 electron, minus 3 electron. Minus 3 plus 3 get cancelled. Initial electron is 5 electronic charge. Now, according to the conservation of charges, initial charge will be equal to the final charge. These are the sets of final charges. It should be 5 electrons. So let's add 5e plus 5e, 10e, 10e minus 4e, 6e. No, we need 5e. 6e plus 6e, 12e, 12e minus 7e, 5e. Correct. So B is the right option. You can check others also, they won't come out to be 6e. This is 10, this is again 6e. Wrong. This is 12e minus 84e. Wrong. So only B option is correct. If this becomes plus 6e, if this becomes plus 6e, and this becomes minus 7e, initial charge and final charge will remain the same, and conservation of charge won't be violated. Is this question clear to you? This came in your section A, multiple choice question. Okay, लिख लो एक बार. Then we'll discuss two more questions.
Done.
Look, one more question, let us see. This is an object has a charge of 1 coulomb. Now, this is a very slight tricky question. Concepts are the same. You should just understand it, the language. You should just understand the language of the question. An object is there. It has a charge 1 coulomb. See, this is a sphere. This has a charge 1 coulomb. It is saying an object has charge of 1 coulomb. This gains how many electrons? 5 into 10 to the power 18 electrons enter into the body. What will be the net charge now? Class, if instead of this language, if the question said that a body is there and it has 1 coulomb of charge and 2 coulomb of charge has entered. So what would have been the net charge now? One coulomb is already present.
Times 1.6, the charge of electron.
No. 1 coulomb, I am saying 1 coulomb is already present in a body. 2 coulomb has entered. What's the total charge now?
3 coulomb.
3 coulomb. Exactly. Or if I say minus 2 coulomb has entered, you would have said the net charge is minus 1 coulomb. Right. But the question, instead of telling you how much exact amount of this coulomb, how much this coulomb has entered, it has rather giving you the number of electrons so that you can multiply it with E and then get the charge. So there is just one additional step here. See, if let me calculate how much of charge has actually entered. Charge gained by the body. So Q is equal to N into E. Q is N is given as 5 into 10 to the power 18. Electronic charge. Now, since we have to deal with the charges, we have to take the negative sign also. So it is minus 1.6 into 10 to the power minus 19. So charge will be minus 0.8 coulomb. So see, instead of directly saying that minus 0.8 coulomb has entered the body, it gave you the number of charge. Now you can relate it like this. If 1 coulomb is already present in a body, 0 minus 0.8 coulomb has entered. So the net charge will be now 1 plus minus 0.8. That is 0.2 coulomb. This is the new charge now. Got it?
Yes, ma'am.
One question based on NCRT is left. That one question I left here. So this is a question from your NCRT. This is a question from this chapter, but nothing from this chapter is used. All your chemistry will be utilized. So I'll discuss that now. Please write it right here.
Ma'am, done.
Okay, class, look, now this question says calculate the number of electrons in one glass of water. So this is a question from your NCRT and it's a very vague question if you see. And class, this question has no relation with Q is equal to any formula. But we'll solve it with the help of chemistry of your class 11th, first chapter, mole concept. Through that, this question is solved. So when it says one glass of water roughly means 250 centimeter cube. Now, class, do you know the density of water? Hmm? Anyone?
No, ma'am.
See, now from now onwards, try to remember the density of water because it is often used in the exams in the form of numerical. So it can make the numerical tough just by putting the density of water. So density of water in SI unit is 1000 kg per meter cube. And the density of water in the CGS unit is 1 gram per centimeter cube. Now, this is the volume of water. Volume of water is 250 centimeter cube. This is 250 centimeter cube. Now, density of water is 1 gram per centimeter cube. Now, if I want to calculate the mass of water, what will be the mass of water? The density is equal to mass by volume. So mass will be density multiplied to volume. So mass will be density is 1 into volume is 250. So mass becomes 250 grams. Right? So I've got the mass. Now why did I calculate the mass? I calculated the mass to calculate the number of moles. Number of moles is equal to given mass by molar mass. Remember class 11th chemistry? All of you must have done. करा था कि
Yes.
नहीं?
Yeah, it's
Marwa,
there
what
in
about you?
first chapter of solutions for class
Yes.
12th as well.
Oh, okay. Yes, yes. In your solutions also it must be there. Solvent, solute and all, no?
Yes, ma'am.
Yes, ma'am. Okay. Given mass we have calculated it is 250. Molar mass of water is 18. This much amount of moles we have calculated. Now, why did we calculate the number of moles then? To calculate number of molecules. Now, number of molecules is number of moles into Avogadro's number. So, 250 by 18 into Avogadro's number is 6.022 into 10 to the power 23. Okay, so 250 by 18 we have written. Now, when you solve this, this will come around 8.44 into 10 to the power 24 something. I have not calculated it right now. This is a value I think I remember as far as I can remember is around this. So don't rely on this value or learn this. Just solve it properly. Okay, so I think it will come around like this. So these are what? These are the number of electrons. These are the number of molecules. We have got the number of molecules. These many molecules. Tell me, here is it here?
Yes, ma'am.
Okay. When we talk about the water, H2O, it is made up of 2 hydrogens and 1 oxygen. The number of electrons of oxygen are 8 electrons and 1 electron for each hydrogen. So, total electrons in one molecule, this is just one single molecule of water, in one molecule of water is 8 plus 1 plus 1, which is 10 electrons. So in one molecule, you have 10 electrons. So in this much molecules, you will have this much into 10. So number of electrons in 8.4 into 10 to the power 24 molecules of water will be 8.4 into 10 to the power 24 into 10. That is 8.4 into 10 to the power 25 electrons. And that was the question. Calculate the number of electrons in one glass of water. So this much amount of electrons. Is that clear? See, I know this is not related with your physics quantization of charge and everything, but this question is a part of NCRT. And when you will solve it by yourself, you will face a lot of trouble because nothing is given in the question. So that's why I discussed it. And one more thing, class, this comes in the board exam also because it's a little different. But this is the only solution to it. Use your chemistry and solve. Yeah, Marwa and Aisha, are you both understanding?
Yes, ma'am.
Oh, write it then. Uh, Probably you just have the class. I think 15 more minutes are left, Aisha.
Okay, ma'am.
Class, have you completed? Okay. Any doubts? Anything you've not understood?
Ma'am.
Okay then. See, this completes with the complete concept of electric charge and the properties of the charges. So the first numericals that can come from this topic is the formula Q is equal to any. That's an important formula and a very easy